Tengan en cuenta que lo que decimos en este vídeo es aplicable a todos los transmisores Laumas, no solo a los multicanales de los cuales estamos hablando hoy.
Hello, I will now show you how to calibrate a Laumas device. In this example, we will use a TLM8, a multi-channel transmitter, but what I'm going to say can be applied to any other Laumas device. We will first start with what we call theoretical calibration, which is basically entering into the device nominal values for load cells and system. Before we start, a quick technical note about the word calibration. We use it for traditional reasons, even if it is not very suitable, because it has a well-defined metrological meaning, which is related to measurements and not to changing devices parameters. The right word here would be adjustment. Okay. Entering the menu with Enter plus ESC, we get Calib. Enter, and we see FSTO, which is the total capacity of the system. If you have more than one load cell, you have to put here the sum of the capacities of the load cells. In this case, we have a total capacity of 80 kilograms, so I will type here 80. The next parameter is sensib, which stands for the load cell's sensitivity. Here we have different cases. If you know the measured real load cell sensitivity, you can put it here. If you have more than one load cell, type here the average of the sensitivities. In many Laumas load cells, you have a label with the measured sensitivity, and you may also find it on the test certificate coming with every cell. If you don't know the measured sensitivity, type here the nominal value, or the average of the nominal values if you have more than one load cell. In this case, I don't know the measured sensitivities, but I know that all the load cells are 2 mV over volt ones, so I will leave here 2, the default value. Next is DVIS, which is the system's resolution, the minimum weight variation you want to appreciate. The device automatically proposes a value which gives you around 10,000 total divisions. We will keep it. Okay, now the theoretical calibration is over, and we start what we call the real calibration, that involves having sample masses and operate on the real load receptor. If you have a multi-channel device and you want to do a digital equalization, this is the moment to do it, before the real calibration. There is a dedicated video about equalization. Let's start the real calibration. The first thing to do is to perform a zero. So unload the platform and press Enter. You will see the weight value sensed by the device. Press Enter again and you will get 0. Enter again to go on. Now you see IMP0, which is a very special menu, and I will not talk about it today, because you normally do not have to use it. The next important menu is weight. This is the weight correction menu. In some cases you could avoid it, but the accuracy you will get will be quite low, in the order of some percent. So you normally should do it. Put a known sample mass on the scale. The closer the value to the system's capacity, the better. In this case, I will use 40 kilograms, which is 1/2 of the system's capacity. 1/2 of the system capacity is the minimum weight we recommend for real calibration. Let's do it. Okay, press enter. You see 42 dot something, but we know it must be 40, and so we correct it. Enter, enter again, and back to the weight. Okay, it's done, the system is calibrated.
Entonces, tengo que decir solo una nota sobre este vídeo. La función de linealización con la cual puede repetir el último procedimiento que hemos visto, o sea, la calibración real, podemos hacerla hasta incluso 5 veces. Esto normalmente no es necesario porque el sistema es bastante lineal, pero pueden usar esta función para compensar